This video DC to DC converter, otherwise called the DC chopper, we will see the basic functioning of principles of operation of DC chopper. So here DC chopper is a power electronic device. It is a power electronic device which converts the input fixed input voltage variable output voltage. Variable output voltage. That means if I am giving 12 volt supply, I can get 10 volt supply. I will get a 10 volt supply or 12 volt supply or 5 volt supply. So even from the input voltage I can get lesser voltages. Again, even for the fixed input voltage I can get more than 12 volt, that is 15 volt, 16 volt, 20 volt, like that we will get. So if the output voltage is lesser than the input voltage, we can call it as a step down chopper, a step down converter or step down chopper. Again, it is just opposite to when the output voltage is higher than the input voltage, we can call it as a step up chopper. Step up chopper. So first we will see the basic elements of a chopper. So first of all the choppers, all the DC to DC converter must have any transistor element. It may be a PGT or it may be a MOSFET. So that is a fundamental device, power electronic device. It is a power electronic device used in the first device. In addition to that, we have the next device called a diode to assist one direction current flow. That we have the diode, and also we have the inductor and capacitor, that is elements, commutating elements are in the third. In addition to that, we have the input and output. So these are the basic elements of any DC to DC converter or any DC to DC chopper. So first of all, we must know, we will see the step down chopper. So step down chopper, this is a circuit diagram. This is a very basic fundamental step down chopper, which consists of input voltage, and we have the switch. The switch may be a power electronic device and also resistive load. So the explanation of this mode can be explanation of this circuit can be understood using mode 1 when the switch is on. When the switch is on, so this is the circuit diagram. When the switch is on, so by the time there is a current flow. That current flow we can call it as I0. Supply voltage is Vs and output is V0. Again, so that time we will see that we will draw the waveform. So this is the input voltage, supply voltage is Vs. So the height of this voltage is Vs. The x-axis we have the time, and the output voltage, output is output V0. When the switch is on, the output voltage and input voltage both are parallel circuit. So the output voltage is nothing but whatever input is having the same height, also we have the output voltage. So this output voltage is present as long as that the device is on, the switch is on. So till that time the output voltage is present. Again, coming to mode 2. When the device is off, like this, we have the by the time there is no current flow, there is the I is equal to I0 is equal to 0, then hence V0 also 0. There is no output voltage, so V0 output voltage is 0. So this we can call it as off time. Again, the switch is on. Coming back coming back, the device is on, mode 1 repeats, the output voltage is Vs, output voltage is 0, that is for off period. So mode 1 and 2 getting repeated. And the third waveform is the I0. I0 is nothing but a load current which is same as the input output voltage waveform. Since the resistor load is used, so the output current is also same waveform as current. Now here we must know one term called time, that is equal to on time and off time. On time and off time. So once again we will repeat the waveform here. So this is the output waveform we are getting from the V0. So even though this output is a DC, it is a pulsating DC, we need to find the average value. So average value we can call it as V0, that is equal to area by base. So this base value, this is on time and this is off time. So combined together, this is a total time. So total time, so that is a one time period. So this base is nothing but one time period, so therefore it will be taken as T, and it will be taken as capital T, and we must integrate over the waveform, that is integration, area is integration over T, and of course supply voltage is height is Vs, so Vs into T. So Vs we can take out. So the limit of the integration is reduces to 0 to T on into Tt. Since the waveform is present only up to T on period only, Tt. So Vs by T, T, and when we integrate this upper limit and lower limit, so substituting upper and lower limit, we have T on minus 0, so that is equal to, this is capital T, Vs into T on by T, so that is Vs into alpha, where alpha is nothing but T on by T, alpha is T on by T. So output voltage is equal to alpha times Vs, so this is the this alpha we can name as a duty cycle or duty ratio. Alpha is nothing but a duty cycle or duty ratio. The range for alpha value is from 0 to 1. It will lies from 0 to 1. Right. So this is the case for average output voltage. Again we will see the second equation is nothing but I0. I0 is nothing but a load current, that is voltage divided by resistor. So voltage alpha into Vs, this is called voltage V0 divided by R. This is the second formula you must remember. I0 is equal to alpha times Vs divided by R. And the third one is RMS output voltage. RMS output voltage. RMS is nothing but a root mean square. That is equal to, we must take the root. The root is nothing but 1 by 2. Then square the input. Then mean is nothing but average. Average is just before we have seen the formula is 1 divided by T, integration 0 to T dt. Now simplifying this integration, we will take a Va square divided by T. The integration is reduces to T on dt whole divided by O. So that is equal to Vs square by T. So that when we simplify this integration, we have T on whole by 1 by 2. So when we take the square root, Vs is the outside. This 1 by root 2 is nothing but a square root. So T on by T. T on by T is nothing but alpha into square root of alpha into Vs. T on by T is nothing but alpha So output RMS V naught RMS is equal to square root of alpha into Vs. And similarly, we can also calculate I naught RMS is equal to V naught RMS divided by R. So V naught RMS, I naught RMS we have calculated. And the types of chopper based on some parameters criteria, the choppers are classified into different types based on the input and output voltages. Just now we have seen step up chopper and step down chopper, and based on the direction of the output voltage and current, suppose we get output voltage positive, output voltage negative, output current positive and output current negative. Based on that we have the different types of calculations configuration, that is called a class A, class B, like this it is going on. Now based on the circuit operation, first quadrant and two quadrant and four quadrant, based on the circuit operation it will be classified into three types. Again, based on the commutation methods, suppose for some cases we are using SCR as the switch. When the SCR is used, we must have some commutation circuit. Based on the commutation methods, it will be classified into voltage commutated chopper, current commutated chopper, load commutated chopper, and impulse commutated chopper. So these are the broad classification of chopper based on some criteria. Right.